going to be less than 6 minutes.
Right.
And then my null is going to be greater than or equal to 6 minutes. Because if we set it flip set, and we really did think it was going to be less than 6 minutes, we ended up failing to reject the null. And that's really not a conclusion. Because we always want to reach a conclusion.
So we have to be careful with how we interpret the question, because that was kind of tricky. It's like, what can happen in the future? It gives you that indication that that's the alternative. It's
So like
not a
that's
no.
where I'm getting mixed up.
No, I'm just gonna be,
Yes.
so I don't need homework 3, I just do the midterm, so I'm gonna just do it out there while you teach homework 3,
Okay.
and then afterwards. Okay.
And then it's just my question is. So I understand that it was giving alpha, okay, and the alpha is kind of like your begin of.
Let's call it our critical value.
Yeah.
So that's what we're comparing.
Critical.
Level of significance, critical value, either one of those two.
So I'm always stuck on, is this information significant just because of our last class, because of our microecon class? Like everything we were talking about was like, was this data significant? Did this? So I'm always stuck on that, and I don't know if I'm wrong.
So you remember when we did in our last class, we did regressions, and it was like, is this variable significant?
Right.
It's the same idea.
Okay.
We're doing the same concept. Is in that class, we had levels of significance of 1, 0.05, and 0.01, remember?
Yep.
And so for this class, those are basically the same thing. They're the same values, but our kind of base
Is the 05.
is a 0.05. So if it's not specified, we're going to go 0.05. Most of the time, it's going to be 0.05.
So then when it's asking, say like it throws the alpha, so it's like, well, if the alpha is now the 0.01,
Mm-hmm.
I guess I'm like, where am I looking?
Look at your p-value.
But the p-value, lower, upper, or 2 till. This is where I'm confused. I don't know.
Oh, it depends on what test it is. So it depends if your test is constructed. So here we have, this is going to be an upper tail test
How do we know that?
because of the signs.
Oh, the signs.
Greater than means upper tail, and in your book,
Wait, is it really the sign?
Yeah.
Okay.
Well, and I also think about
The signs compared to my alternative hypothesis.
Yes,
That's how I'll know.
which is what we're trying to put.
Yep. And I'll find
I just needed that.
You know, it's just-
That's all I need. It's just those
It's
little
not terribly
things.
intuitive sometimes.
It's really not.
that's how you anchor the knowledge, by asking,
Always
and
with-
little by
Yeah,
little,
putting it
you're
together.
grabbing more, and you're
But I'm
sinking in.
sitting here reading this book and just like, then I started watching YouTube videos, which actually was kind of helpful. Since I'm a
So
down.
you're more confused.
On YouTube videos?
No.
Oh.
I didn't get
So here, this
Okay,
page,
oh yeah, the one I marked.
this one's going to tell you upper tail, lower tail, 2 tail
Yeah, I
test.
didn't understand it.
What page is
This
that?
Greek to me.
So it's all about this. So this, and lower is lower and lower.
So if it's pointing right, it's upper.
Determine this,
Okay.
which p-value.
So if the null and alternative look like this with the signs, that's what we're gonna follow.
So if it's greater, yeah, if it's less than, lower, if it's greater than, upper, if it's not equal to tail.
So I gotta just.
And then what you do is, like you said, alpha value, you just compare this value to your p-value.
Right, and then I'll know to reject it or fail.
Yep. Oh, we
Now
don't
I
know
understand
how to
why we
reject
say
or accept.
So-
Yeah, I
Yeah.
have no freaking idea what
No,
to do.
I understand because I watched a YouTube video, I
You
understand
don't know
why you
it?
don't say
Thank
accept.
you.
I get it now.
Well, I read the
Why would you
book.
say that?
If you read the book, the
That's very
paragraph talks about level of significance. It says the same.
Plug a formula in Excel.
That when you
But
care to
then
reject, you
understand
cannot
why
take to
it's there.
accept, when
Accepting it.
you're not accepting it because there's a level of error that can happen when you accept something that is not fully correct.
Yeah, it's all about, yeah, what you're proving. And then we can get more complicated with it, but it's just this. When we run a test like this, we can prove one thing, or we can prove nothing. That's the best way to think. It's much harder to, I mean, we're more or less disproving something, and by disproving something, we can reach conclusions in a way. But
My only other question that I was completely confused about, which now this is all put together, is the templates. I don't know which one to use because I don't understand. Okay.
Okay, so let's
I'm
open
like,
up.
is there population? I don't know.
Yeah, that's what I struggle too. I need
So-
flashcards.
Yeah.
How
Just
can I-
very-
Let's review this real quick. Open.
I mean, I think I'm looking at it. So we're all for the same thing. I'm glad that we all know that we're on the same, like stuck on the same question,
Yes.
or at least
It's not one question.
the questions.
Let me just be clear.
Let's just say I didn't do trick or treating with my kids today because this was stressing me out so much. I'm like, I'm sorry. I have
So are they gonna go with your husband?
and my cousin actually.
I just left a bucket of candy
It was,
for the kids in my neighborhood.
I was like,
That's
my
cool.
husband's like, are you freaking kidding me? I'm like, I'm not kidding you.
I know.
They'll be fine. I've done 14 years of this. I think.
We can handle
I know, I
it.
didn't even see one costume today. No,
Do we open your template?
I'm not.
Yeah. Open up this. So either one, this one. This is all later on.
What? If it's greater than.
So let's look at our midterm. So we're gonna have. This question says, the data below, the time it took to, that doesn't. Data below is the time it took to complete a telephone survey for a sample of 35 calls. The company wants to know if the surveys can be completed in 15 minutes or less. The population standard deviation is equal to 4 minutes. So we're given the population standard deviation. So if we look at mine versus yours, but I don't have yours, I know it. Yours will say on yours whether or not it's population standard deviation is known or population standard deviation is not.
Okay.
So if we're given the population standard deviation, we're going to use the one that has our standard error and our test statistic. That's with a population standard deviation that is known. If the population standard deviation is not known, then we are going to have to start using our push. I'm going to use our t distribution instead of our z distribution.
Can you say that one more time?
So,
T-test, yes?
yeah.
Same thing?
Mhm.
So the other one is the Z-test.
Yep. If we know the population standard deviation,
Okay.
then we're going to be using our norm.dist for our p-values. And if we do not know the population standard deviation, we're going to have to be using our t.dist for our p-values. And if you look at my templates, they're not as pretty, but you can figure it out. I've labeled them data with population standard deviation, and then data with no population standard deviation. So if you're given a sample standard deviation, then you use this one. Standard deviation, then you use
I just need to put those words in.
So what was the other one? You said with no population, what's the other word for that? When you don't have population, just no population?
I just put population or no population. When you do not have your population standard deviation, they're going to give you a sample standard deviation. So if they say sample standard deviation, then you know that you do not have a population. So there's two types of standard deviation. There's a population standard deviation and there's a sample standard deviation.
Correct. So that
So
would be the X with the bar, right? Or am I confused?
that's your sample mean.
Oh, okay, okay.
It'll be a little standard deviation guy, which I believe your standard deviation guy looks like this in your book. Your little standard deviation guy,
Oh, yeah, yeah.
but then his little subtext will be X bar. This is a terrible, terrible marker. Why would you have a wine and green?
So that's for the way.
I'm not sure.
So with population standard deviation is the Z-test.
Mhm.
Z-test.
And
And then what's your second?
And using the standard error.
using the standard error on both of them, but because now we're doing a sample. We're testing a sample
Yeah.
against a given mean.
Yeah.
Amber, say what you just said.
So when we're given the population standard deviation, we're going to calculate our p-values. With population standard deviation, we're using norm.s, norm.s distribution, because we're doing a z-test. And if we do not have our population standard deviation, we're using our t.dist distribution, because we're using a t-test. So that's how you can tell the difference between the two. First off, your nicer templates will have up in the top whether it'll say population standard deviation known, population standard deviation not unknown. But then also you can look at how these p-values are being calculated, whether it's t-dot distribution.
So the C test is the one that we're looking for the C score, correct? Like the
Z-test?
what you just said about the C test for the when you know.
Z-test. Z.
Correct.
Oh,
Well, it's my accent.
I thought you said
Yes,
Z.
Zorro. Okay, Z.
The Zara test.
The Zorro. Then that's when you get the C score.
Mhm.
When you have the distribution and you're
Yeah.
trying to find, and then you go to the table,
Mhm.
and then you know exactly.
Yep.
Okay.
Mhm.
The table.
And then let's discuss something else that I got a couple questions on.
Yes.
So 40 on this one says, what is the exact value of the test statistics such that if the t is less than that value, we reject the null hypothesis. And if t is greater than that value, we accept the null hypothesis. So in my template, it's going to be your t critical value. Yeah, so it's going to be our t critical value. My template, I didn't put that in because I don't know if this question came up last time. It should be in your template though. But the way we can calculate it is we can say, what we're trying to say is we have a distribution, and we know there's a point that references our alpha value. And if we're doing, we'll call this an upper tail test. If we're doing an upper tail test, if our observation falls above that alpha value, we're going to reject the null. If it falls below that alpha value, we're going to accept the null. Now, if we're doing a p-value test, and this is why p-value tests are so much easier, is this, if this alpha value is 0.05, then is our p-value less than that? Is our p-value greater than that? If it's less than that, then we reject the null. If it's greater than that, we fail to reject. But if we're doing a t-test instead, we need what's called a t-critical value. So the way we're going to do that is t inverse. So we want to find, we're given a probability value at our alpha, and we want to find an actual t output value. So the probability we're given was 0.05. Our degrees of freedom remains the same. So we're saying here, so what we're saying here is going to be, we're going to be comparing the absolute value as well. So at 0.05 or 0.95, whichever one is going to be the positive or negative of the same value. What we're saying is for this test on page 40, the question 40 of the midterm, you are doing a lower tail test. So what is the exact value of the test statistic if the t-value, were less than that, or t-value, t-value is less than that value?
Oh, what in hell? I learned that on Sunday, but I could not.
I'm sure I read it.
Since we're doing a lower tail test, our t-value is going to be negative. So we want to find what this value is, and if our test statistic is less than this T critical. Okay, have you guys learned about absolute values?
Mhm.
It's much easier to think about these things in absolute values. So we have our T statistic. We're gonna take the absolute value of that. When we look at our template, our T statistic is this test statistic. So this negative 2.35. That's our T statistic. So we're gonna take the absolute value of that. So the absolute value of that is 2.35. And then our T critical value is what they're asking us for. Our T critical value is a value that if our absolute value of our T statistic is greater than, then we're going to reject the null. And if our absolute value is less than, we're going to accept the null. And the reason why I'm taking the absolute value is if we look at an upper tail test, if our T is greater than this alpha value, if it's greater than it, we're going to reject the null. So if we're in this area, we reject the null. Now, if we look at a lower tail test, and it's a negative value, if we're less than, but if we take the absolute value of that, it's greater than it both ways. And so that we don't have to memorize greater than, less than, back and forth. We just say, take the absolute value of both numbers, whichever one is greater. If it's greater, then we reject the null, and if it's less than, we fail to reject it, or we accept the null. On 40, if this question were 40 and these were the answers of 40, which they are not, they're slightly different, and I wanted to find a T critical value that the way it says, if it's less than, it's greater than or equal to, then we fail to reject. Since we're doing a lower tail test, my T critical value would be this right here. Given that I type in 0.05 and then my degrees of freedom is 49, because your T distribution is dependent on the degrees of freedom. So the way you find the answer for question 40 is we find this T critical value using T dot inverse of our alpha, which I assume is 0.05, and our degrees of freedom being the same.
It's not.
It's not? Oh, okay.
It's 0.01.
Okay, well, he's changed it to 0.01.
Thank you.
So that's a little, in your templates, it might give you that, the ones from the book.
So we're just punching in the T critical value in that question.
Yeah, because when it's asking, the way the question words it is saying, give us about, and for this one, since it's a lower tail test, it's going to be a negative number. It's going to be the negative value. So it's just saying, give us a value. What they're essentially asking is, given this probability percentage, 0.05, give us a value. Which remember from earlier, that's when we use our inverse equations, is when we're given a probability area and we want a value instead. So it's saying, what is that value where if our if our T value, absolute value is greater than it, we reject. And if our T value, absolute value is less than it, we fail to reject.
So basically, it's just telling you that what type of tail test it is,
Mhm.
and then we just calculate the T critical value of it there.
Mhm. But this is why I said last week, I like p-value tests better than
Right.
t-value tests,
For sure.
or z-tests or t-tests, because then we have to calculate both a z-value and a z-critical value. So we have to calculate a test statistic and then a critical value, and then we compare the two. Test, we just find a test statistic, and then given that test statistic, we get a probability area. And given that probability area, we can compare it to our alpha, which you don't have to calculate. So one less bill.
Perfect. That was my highlighted question.
So you said it was a T test for number 40. We need to find the T critical value.
Yep.
Test. And that would be basically when you don't know the population and you need the T distribution.
Yep. So this one, we're not given the population value. the sample standard deviation. It gives us a sample standard deviation. If we're given the sample standard deviation, we know we do not know the population standard deviations.
Just real quick, Matt, when it
Yep.
said, I'm sorry, I'm just trying to wrap my mind again. The p-value, we reject it if the p-value is
Less than
less than the
our
alpha.
alpha. Yep. So p-value, if it's less than, we reject. And then if we're doing a t-test or a z-test instead of a p-value test, if the absolute value of our test statistic is greater than the absolute value of critical value,
Right.
then we reject.
Or,
So we
in the
reject
t-test, I'm
it.
sorry.
T-test, yeah.
T-test.
P-value, they flip.
Yeah.
They flip and flop.
Okay.
So if the absolute is greater than the absolute of the
It's a-
alpha,
Yeah, so
then you,
it's if the absolute of the test statistic is greater than the absolute value of the critical value.
Which is the alpha.
And the critical value is calculated through the alpha.
So that t critical value that we calculated.
then reject.
Then we reject, yep.
So when you're done with this class, this Wednesday, and the only thing really left on our mind is the final,
Mhm.
you do like a review?
Yep. So we'll have, 2 weeks after Saturday,
Are you giving us any more homework?
which we'll have homeworks, right? We'll get 2 more homeworks. So what we'll do is, those homeworks are essentially a review for the final.
Okay.
So
Very good.
we'll probably do the first week going through that homework, and the second week we'll do a final review. I'll send out a review. The review will be mostly, since your final isn't cumulative, it's only the first half and the second half.
Oh, no. So midterm the first half and the finals the second half?
Yep.
Okay.
Uh,
So I have all of these pre-built templates
Nice.
Oh,
for all of these questions. So you'll all have this in your final, and we'll walk through this and we'll kind of focus on, one, how these work, but we won't focus on that so much since they kind of work manually already. But we'll focus on when we use what and how we identify when to use which ones.
yes.
So I still try to figure out how to build that.
So we did a little hypothesis stuff earlier. Let's do a little bit again before we move on. So we have our null, then we have our alternative hypothesis. So if ever we have a target or we're given a goal, where we're trying to prove something or we have an outcome that we think is going to be likely, that's always going to be our alternative hypothesis. So this is going to be a target or a goal or idea. The Y idea. Sense. So if we're targeting something, and we have an outcome that we are hypothesizing to be true or we think will be true, it's always gonna be here in the alternative. And the reason being is if we reject the null, that's kind of the only true outcome from this test. You either have a test that proves nothing or we can have a test that rejects the null. So that's why I don't like to say accepting the null, because we're not really accepting it. We're just kind of not proving it. So whenever we have a goal, always shoot for this one. I mean, whatever our goal target is, we put it in the alternative hypothesis.
So whether it's greater than or less than, whatever it's asking, you put there first, and then the null is opposite of that.
Yeah, so let's do a couple of walkthroughs. Okay. Which is cheaper, eating out or dining in? The mean cost of a flank steak, broccoli, rice, bought at a grocery store is $13.04. So we're given our first mean value.
Which page is that, Matt?
436. So the mean cost of a steak dinner is $13.04 from the grocery store. So we're gonna sample 100 neighborhood restaurants. And so it says here, develop an appropriate hypothesis test whether the sample supports conclusion. 27, so whether the sample data supports the conclusion. So here's what the conclusion is. The conclusion is that the mean cost of a restaurant meal is less than fixing comparable meal at home. So we're running a survey, and we think our conclusion, what our hypothesis is, what we think our conclusion will be, is that the mean price of buying this whole meal at a restaurant as opposed to at the grocery store is going to be less than buying it. Buying at a restaurant is going to be less than buying it at a grocery store. So our alpha value, or our mu value, I'm sorry, is price at diner. So whatever we take a survey of, whatever our survey results are always going to be that mu value. That's our survey results. So if we're trying to prove the conclusion that it's cheaper to eat at the diner for this meal than it is to buy at the store, our alternative is going to be that our diner price is less than $13.04, and that makes our null the opposite, greater than or equal to. So 28 says, a shareholders group is lodging a protest claimed that the mean tenure for a chief executive officer was at least 9 years. So we're given a claim or an average that we're comparing against, and that claim is 9 years. So it says, a survey of companies reported that the Wall Street Journal found that the sample mean tenure is 7.27 years, a standard deviation of 6.38. Formulate the hypothesis that we use to challenge the validity of the claim made by the shareholders. So shareholders are saying that CEOs, on average, are in their position for at least 9 years. So they're saying at least 9 years, and we're trying to disprove their claim. Bless you. So we're trying to disprove their claim. We're going to say that they're in power for less than years. And our alternative, we just follow through with kind of the opposite of that.
And because they gave us the standard deviation, then we can run a z-test on this one.
So this one gave us a sample standard deviation, and not a population standard deviation. And that can be denoted by always a population standard deviations, and your questions usually be denoted by this. And in your book, your sample standard deviations are going to be notated by the lowercase s. But they give you a sample standard deviation because they give you the sample mean. So the way it says that is the sample mean. So a survey of companies found a sample mean of 7.27 years and a standard deviation of 6.38. So that's the sample from that's the standard deviation from the sample in the survey, and not the sample from the population.
So when it's the sample, then
Or you use a z-test.
okay.
Z-test and t-test.
Oh,
T-test, that's e-test. They sound the same.
so the word sample is being used.
If sample is being used, we do not know the population.
Okay.
And if we do not know the population, then we have to use the z-test because the t-test.
Okay.
The video is like messing up.
Yeah.
T-test. We have to calculate our degrees of freedom when we do not know the population standard deviation.
So now, quick question on this one, because the verbiage here, it says at least 9 years. So the way I take this is that it's 9 years or less. You know what I
At
mean?
least means 9 years or more. So if I say someone works for at least 9 years,
Okay, okay.
that's 9 and everything above.
Makes sense.
And so we're trying to disprove their claim.
Okay.
So let's look at tip 29. The national mean salary for a school administrator is $90,000 a year. A school official took a sample of 25 school administrators in the state of Ohio to learn about salaries in the state and if they differ from the national average. Formulate a hypothesis that can be used to determine whether the population mean annual administrator salary in Ohio differs from $90,000. So we can just, 90K is the number that we're comparing against. That's a national average. And now we're taking a sample, and the sample is going to be Ohio's wages. And so the question says, form a hypothesis to prove whether or not Ohio differs from the national average. So differs doesn't mean above or below. It just means, is it different than?
Not
So-
equal to.
What?
Not equal to.
Yeah, not equal to. So if it's just differs, if it's not equal to, or is it different than, then we do equal to, not equal to. Not equal to is always an alternative. Because that's what we're trying to prove whether or not they're different.
Yeah, it's a two-tailed.
Two-tailed test, yep. That's on page, she knows the page. What page is the, who is this person?
It's 424.
424, notate 424 in your books. It's an important page.
I got dog eared.
Oh, yeah.
I might make it, guys. It might be in the next picture.
That means somebody else.
Yeah, it's just like-
I know.
You guys keep losing people or what?
Yeah.
No.
Every time I take another picture.
It dropped in like flies after the first one.
How many people I like, I can't remember, the redhead lady wasn't here.
Michael.
Yeah.
And then
We still got one over there.
3.
Sometimes, like, the classes like bleed together, and then I just lose this memory of like, which one is which
That's what I feel about our instructors.
Excluding you, Matt. Yeah, you have to say that.
Okay, I don't know. What's really weird is when I go to like functions, and then like, I like see people who like I should know, and I'm just like, oh yeah.
Have you been in
The thing,
the
all this stuff,
house area?
the stuff.
Psychology, you do psychology? You get a term for that. When you see somebody have context and you don't recognize.
You know, we could do a few of the midterms,
You can't do the midterm questions.
because I'm stuck in a few and I cannot move forward.
There's one about like a threshold. Oh, it was working with probability that I was.
I can move
It's
forward
tab
like
D.
2.
What's the midterm question?
I guess my question was when to use the 1 minus inside the
Oh, okay,
brackets.
we can talk about, we can ask questions about midterm.
Yeah.
So, if we're given, so there's two cases when we're using our inverse and our distribution. So if we're given a value, and that value can be a z-value, that value can be a dollar value, that value can be in pounds, and ounces, et cetera, et cetera. We're given a value, and we want probability. Then we're going to be using norm.s.dist or norm.distribution. So this is the way that function kind of works. We think of it kind of as a machine. So we're given this value, and we plug this value into the machine, and what does the machine output? It outputs a probability, which is in a percentage. And it's always going to give us the area to the right of a point. So if we want the area to the left, we have to use a 1 minus. So for this, 1 minus because the reason why we're doing the 1 minus is we assume that if the area to the right is a probability, the area to the left is going to be a perfect complement to that 100% probability. So we always want a 1 minus where our probability is and not where our value is. So for this one, we do it outside of the function. And this gives us our area to the, I'm sorry, gives the area to the right, my bad. The function gives the area to the left, this gives the area to the right.
So if we're trying to figure out the probability that something is a value, a dollar amount more.
So what's the probability that our hospital bill costs more than $200?
Yes.
Then we do 1 minus norm.dist, $200, enter our mean, enter our standard deviation.
So I have that, but what if it's talking about thresholds? I guess.
So
Is that the one that you have, the one in the middle, and you have to?
It's
Take
asking
out
like
the
the
left?
like if you're looking for like the highest percentage. Tab D, question 25.
The midterm?
the highest,
It's like the,
okay.
this is where I was like, don't you do
So-
1 minus in the parentheses?
Yes, let's talk about the other thing. If we're given a probability,
Tab D, question 25.
so we're given a probability, and then we want a value. We're going to use norm dot s dot inverse or norm dot inverse.
Can I ask a backup question?
Yep.
The S, means it's standardized,
Yep.
and what gives it away this standardized?
For this class is when you hear those questions where you see the z value in front of it, and it's probability z or z is greater than this, that means we're standardized for your size. For this test, I believe. Z's, whenever it gives us z values and the z is in there, that means it's standardized. We're using s and this.
So we need the probability, right, when we get the C value.
Yeah, no, I mean, it depends which one. So these ones, where we're given these, z's in between two things, we need probability.
Yes.
Here, we're given probabilities, we're given this, we're given z. But z, when z is in the question, we use norm dot s dot distribution and norm dot s dot inverse, because it's already standardized. When z is not in the question, we don't use the s. We just use norm inverse and norm dot distribution. But, so, if we're given a probability, we have to plug it into this norm inverse or this norm s inverse, and then we get a value output. Be that, again, in z's or dollars or whatever. So, if we want the area, and this is going to give us the area, it's going to give us a value where everything comes, let me think about what I'm saying. If we say, what if we're in the lowest 5%? What z value do we need to be less than to be in the lowest? Then we can plug this in, that 0.5 into here, and we get that value. Now, if they ask the question of highest 5%, and we can know one of either two things. We can know that we can either use 95%, because if we're not in the lowest 95%, we're in the highest 5%. But if we don't want to do that, we just want to do the 1 minus, we're going to do our norm dot inverse of 1 minus the probability. And then we're going to do mean and standard deviation. But for this one, since we always want a 1 minus where our probability is, we never want a 1 minus where our values are, because that's going to mess up the problem. We're whenever we do that 1 minus, we want the area to the right, we have to do the 1 minusing to the probability. And since we're inputting our probability into the function, we have to do it where our probability is at. We have to do it within the function.
Okay.
So am I hearing you right? You're saying that the top one, it's 1 minus probability, it's probability, and the bottom one is 1 minus the whole norm?
Yeah, because the norm
Probability?
gives us a probability.
Okay.
So wherever the probability is at, if we want the area to the right, or we want the area to the right, or we want the highest 5%, or however we're thinking about it, we always do the 1 minus, because the reason why it's 1 minus is because it's a complement of a probability. So wherever our probability is, that's where we do the 1 minus. Now, if it's probability going in, inverse, we do it in the function. The probability is coming out of the function, distribution, we do it 1 minus the function.
Hey, Matt, does he want to see this in format of percentages, like with the percent sign, or can we leave it in just the decimal format?
I'm not sure. I would say either way. Or both.
Yeah.
Do both if you want to. I mean, because truthfully, if you leave it as 0.8755, to me, that's a probability. Also, 87.55 is a probability. It's a question of formatting. I'm good with either one. I think you'll probably be good with either one.
If he's asking what's the probability of such and such, do we want to say this and this is 59%, the probability is 59%, or no?
I don't know. I mean, that's a good question. You probably email and ask. I don't want to like lead you astray on that. I would say I would probably not leave it. I'd probably leave it not a probability, not a percentage, because to me, I think about probability more as fractions of 1 than a percentage. Percentage is kind of.
Okay,
So
and I
that's
was
why
viewing it,
you
I view it differently, so that's why I want to know
Mhm.
the right way to look at it. So-
And I would go. You want to make sure you report probably like 5 or 6 decimal places.
I'm not 100%.
He said 3.
Uh-huh.
I'm not 100% positive, but I think Chelsea and I got knocked off. Like a whatever fraction because we put it in percentage rather than decimal.
That's my
Oh,
point.
okay.
It's probably more, from my perspective, and like academic sense, it's probably more proper to not put in a percentage. Okay.
Start moving decimals.
Any other questions on the midterm?
Well, I had highlighted yellow squares here, it said ask Matt.
Which
Well,
one?
I do have a lot of those, but if you say that we
Oh.
cannot go over.
We can't go, I mean, if you have a question on what to do next, I can answer that question. If you have a question about what the actual answer is on the question, I can't.
Mine is still.
So how close to the real question can we go?
What, which one are you having problems?
Which one, yeah.
No, which one are you having problems?
I can help out.
Okay, tab A, let me see.
Just you explaining which, honestly, just the way the tail, that's what was just holding me up. I mean, which tail to look at to reject a null or not.
And usually for most of your tests, I was gonna like sanity check, because if you do a one-tailed test, your p-value for the proper tail is gonna be lower than 2 p-values. The one p-value is gonna be like 9999. It's like clearly not gonna be that one. That's a terrible test.
Oh,
Just frame that way. But
So is that to say that the lower value is always going to be your alternate? Does that make sense on the
I don't think so. But go on. What you're saying?
So, someone, I thought I heard someone tell me that, said just double check it, and, oh, no, not the lower value, but the lower number, whether it's upper or lower.
That's
Tells
good.
you what direction it's gonna be pointing to, the alternate. Does that make sense?
I mean, kind of, that tells you more or less how your tail should be, how your test should be set up. So if we run a p-value test, let's look at this one here. And so without looking at whatever question this was, because I forgot the question we put the numbers from, I can tell that this is probably gonna be an upper tail test.
That's what he said.
Because it's a smaller p-value, I know that's what it should be. Because if I constructed a lower tail test, and I got a p-value of 0.9985, that's a pretty terrible test, because that test, I got nowhere near rejecting no hypothesis. I was making a claim that was nowhere near correct. So that's kind of a good sanity check, is what your p-values look like.
I think I heard something, so I don't know, probably I'm totally wrong, but Daryl said, let me give you a tip or a trick on this one. And for example, when you have this one, the alternative, he said if it points in that direction, that is a low,
Up or down?
an upper.
Yeah.
And if it points, well, we don't
In
have
the
it
opposite
here,
direction,
but if
it's a
it
low.
points this way, the opposite of this, it would be a lower tail. So if you do this, like you follow where it points, like in this case would be upper, both upper.
Yeah, or you
And
can
you focus on this one, not the null, but the
the alternative, yeah.
And in this case, well, you know.
And if our alternative says greater than, we know greater than is gonna be right side, and then less than, you know, less than. So it's like, if his example is good, his example would confuse me, because I wouldn't see a pointing tail, I would see greater than or less than sign. So greater than always means upper tail. And then if our alternative is less than, it always means lower tail.
And
Yep.
that wouldn't be true for this test if the 20, you know, to accept or reject the greater than or equal to 20, that's probably a different question.
It's a different question than that, yeah.
Because that wouldn't coincide.
Because
with
if this, yeah, ignore this
The lower
here,
tail.
this was probably an earlier question of some
Okay.
sort.
Right, and we changed
Because if this was the same question, this would be 20 instead of 15. So say it is 20 instead of 15. Now, these values don't correspond with the
Right.
same.
And if it doesn't give you the hypothesized value,
Mhm.
do you assume it's 0? Or is there,
I think all of your midterm questions are gonna give you a hypothesized value.
maybe I was trying to use something where it's asking for hypothesized value, and maybe I shouldn't have been using that.
Usually it's in the question,
Right.
or at least.
Yeah, hypothesized value is usually gonna be given to you.
I think I might have just like got myself in a world, started using something that was just not even related, you know, to the question.
I had highlighted it on the sample like green instead is given in question.
I can't remember the questions anymore, so I think it's really the homework.
In the homeworks, we're gonna start doing differences between two means. And then our hypothesis value can be 0 and will be 0 a lot. Because we're talking about the difference between two means. Hypothesized value of 0 means that are the means different or are the means not different. So that's,
Yeah, I think so.
Mhm.
but for midterm, most hypothesized value are gonna be, I think are all gonna be given to you. So which one are you having trouble with?
Let me see, I'm looking still. How about this? For sure, number 40, so I took notes on that one.
Yeah, and we kind of discussed that already for number 40.
Yes.
You got the answer?
No, but I'll work on it. Number 36, what is the p-value of the test for the test statistic above?
That's just gonna be your p-value for your test. So you set up what we're looking at here is you're looking at a lower tail test, and you have to do this template, and your p-values could be your lower tail p-value. So if you did this test in my template, and remember this one does not give you the population standard deviation, so you have to use the sample standard deviation. So it would be the no population standard deviation. If you did this in here, that answer would be this p-value for this lower test. Because E gives you the population standard deviation, and F does not give you population standard deviation. So it's all about picking the correct template.
Mhm. Yeah, that's what I think I need more practice. 37, do accept or reject the null hypothesis.
That's going to be based on whatever your p-value is.
You're right.
So can you explain this, because I'm still lost.
For rejecting and accepting.
Yeah.
So if we have p-values, if your p-value is less than your alpha value. So for this question, our alpha value is 0.01. If our p-value is less than 0.01, then we reject the null.
So p-value is less than the alpha,
We reject.
reject. And that's a given, that's like possible.
Yep, always. And that's why p-value tests are always the best test. Because we don't have to monkey around with absolute values. It's just, is our p-value less than our alpha? And then if our alpha changes, our p-value does not change.
We like to reject, right? Because then we're saying that there is.
Yep. Our target is to reject, more or less.
So we reject the null, correct? The null.
If the p-value
If the
is less
p-value is
than
less
the
than
alpha,
alpha.
we reject the null.
There's a YouTube video that said if the P is low, HO must go.
What?
If the P is low, HO must go.
I want to write that down.
Yeah, I was like, oh, well, that was clear. That was clear to me. I was like, why didn't you say that earlier?
The HO
Must go.
must go. I'll remember that. I need a type of
Yeah.
association
That's
because I
fine,
have
too.
nothing to anchor. There's like to nothing. Absolutely, that's fine. Okay, the next one would be, can I share the answers now of what I have so far? No.
Can't change the answers.
Okay,
Just know that for all of these ones that you're asking about for,
Yes.
for tab F, just know that you are not, this is as much as I can give you, you are not given the population standard deviation for this question.
So use that.
So use that template.
okay.
And
Thank
then
you.
on page 38, you can see that your sample mean changes. I mean, question 38.
Oh.
Page.
38, yes.
So something changes, your sample mean and your sample standard deviation are those things that changes. And you can just change those in your template and you'll get your new p-values.
Do I need to paste the new template?
No, you want me, I'll show you how we do it.
You can paste a template right next to it.
Twice, like,
Yeah.
okay,
Yep. Okay,
thank you.
let's move to some homeworks.
Should I call Sean? Or
I think he's working on the midterm.
Okay. But
Ooh,
didn't
what
he
school
say
is-
call me when you're doing the homework?
Oh, did he?
I don't know, he said call me when you're,
Maybe I could tell him we're doing homework and see if he wants to come and answer. Did you have the score up there? Oh, the game?
Oh my
1-0
gosh.
still, I think. What's crazy is like, last week, there was the game we couldn't watch was the fastest game ever in the World Series. And then this week, this game is super fast. And then all the games that we've not been here to watch have
Yeah,
all
he's
been
fine.
like 4.5, 5 hours.
he's fine.
Is it good?
Yeah, he's working on something else.
Early was still pitching into the 6th. Is Hill out? Hill only went 4 2/3. So
See how late class was.
That was her brother-in-law. Or something
Oh,
like
she
that.
knew who it was? Oh, so she can hit him and.
Okay, homework 3.
What did you?
homework 3. Okay. That's homework 3. So researchers collected responses to a satisfaction survey for Kmart and Dollar General. She's trading this type of fish to determine if customers of these stores have similar satisfaction scores. So we're giving 2 score tests. We have score satisfaction scores from 2 different companies. So the first thing it asks us to do is set up a hypothesis. So what we're trying to see is Dollar General's score, and then we have Kmart. And we're trying to test, are these scores different?
So it'd be equal to or equal,
Equal to? Not equal to.
non-equal.
That's going to be our alternative and our null hypothesis.
Is that a DG?
Dollar General. Yeah.
Okay. I cannot see the red ring.
But if for, like, if it's just saying formulate the null hypothesis, we don't have to break it up, or do we have to do it like that?
Well, no, so the first one is formulate the null, and the second one is formulate the high alternative. So,
So we're gonna do DG equals can.
Or do
yeah.
like U1
Yeah.
and U2 or no?
No. For this one, we don't need the U1 or U2 because we're comparing 2 populations now. Before we were estimating the mean of a single population. Now we're comparing 2 structurally different populations from each other.
You can get the answer to this one, can't you?
Yeah.
So if we just put mu equals the mean, x bar, and then the alternate is mu does not equal x bar?
I would put this DG is equal to Kmart, or DG is not equal to Kmart. Or what you could do is you could say something like this, that our mu is the difference between Dollar General and Kmart.
Oh,
And then you can do mu 0, mu not equals 0. But that just kind of adds another convoluted step where you can just stick with Dollar General is equal to Kmart, or Dollar General is not equal to Kmart.
Okay, so I got a question here.
Mhm.
She's trying to determine if customers of these stores are similarly satisfied.
Yep.
Now that would seem to me like we're testing, are they equal to?
Uh-huh.
But when we're talking over here, the alternative is always not equal to. Is that a fair statement?
So we're testing whether they're similarly satisfied or not. Since we cannot put not equal to, we can't put equal to in the alternative hypothesis. So whenever it says are similar, are not similar, are different, are the same, it's just by the structure of it, we have to do equal to, not equal to.
Okay. And not equal to will always be the alternative.
Yep.
Okay.
Because essentially, if we either prove that they're not, if we can't prove they're not equal to at a certain high level of significance, then we're okay with saying that they're more than likely equal. So
Matt, quick question on this one. What if you take one and you want to prove it with the other? Let's say you pick, since you know that Kmart is 79 and Dollar General is lower for the mean of satisfaction, then how about I take Dollar General and I try to see if it can be 79? You know what I mean? Because if not, they're not really that similar if I disprove. You know what I mean? Like instead of doing the two-tail, make it only on the Dollar General with the, not the assumption, but kind of like prove and see if it can be higher.
I
Can you
mean,
follow my train of thought?
kind of. Since we don't have any true population values, we have 2 samples. We have to kind of compare those 2 samples to each other.
To each other.
And if we don't do that, then we're going to kind of mess up. What we're going to end up doing in here is we're going to get standard deviations of the 2 samples combined. And so we're just comparing these 2 together. Now, we could just split off and say, is Dollar General greater than or equal to some value? And then is Kmart greater than or equal to some value?
Yeah.
But we can't associate them together unless we include both of them in the hypothesis. Because once we include both of them in the hypothesis, then we include both of their sample sizes and both their standard deviations within our shared standard deviation calculation. So,
So that's the best way to go when we have two.
Yep. We have two populations,
to
we're always
be
we're gonna
compared.
compare them to each other. Yep.
Thank you.
So assume that the standard deviation is equal to 12 for satisfaction scores at both retailers. Conduct a hypothesis test for an alpha value of 5. What is your conclusion? So there's two ways we can do this. We have a template for interval estimation between difference in population means. And then we can do a z-test for 2 sample means. One is a calculation within Excel and one is a template. So we can do this, we can just say, hey, I'm gonna copy over this template. And then we can just copy over this information into our template. And we know our population standard deviation is equivalent for both. And that change. I have to click on all these. 1 second. Formulas, calculations. Why is it manual? Calculate that. Okay, now we're up to it. So we can plug it all in here. We specify where our means and our sample sizes are. We specify our population standard deviations, which for this, we're assuming they're both 12. Then we're given, we can change here our level of significance, our alpha value. We can change this value, either one. We're given our standard error, we're given our z value. This is going to be our z critical value based off our alpha value. And we're given a margin of error. Then we have a point estimate difference between the two populations. We have an upper limit and a lower limit. Then we have our z calculated value, which is going to a point estimate divided by our standard error. And then we calculate a p-value for that. And it's a two-tailed test for this one. So this is helpful if we need to know our upper lower limit. We need to know if we want a confidence interval of some sort. Some people like doing this because you go step by step with the calculation. The other thing we can do is we can go into data. And data analysis, t-test, t-test for 2 samples assuming equal variances. Oh shoot, we're not getting data on this one, so we have to use that. Who's use this? Never mind. You know what I said. If we don't have the actual data, we just give the values, we use the template. If we have the data, we can use the t-test. So
I have this for the unknown case when
they're unknown,
the unknown.
Which is here. When they're unknown.
Right.
Uh-huh.
Do you know what
Do you
what
not have the
case?
known one?
We don't have the known one that I can find.
It says something with inner city and suburban.
Wait, this one right here?
Uh-huh.
Yeah,
Which case is
it's in chapter
10.1.
Looking at 10.
So Excel files, 10. This one's something with cities, inner cities.
I think it was one of those templates. Templates known.
Yeah,
Yeah.
Set known and unknown. There you go.
Oh, crazy.
So Matt, that final, all these tabs, is that something that you can share with us?
Oh, the final review? Yeah, I can
Yes.
send it out. We might be getting ahead of ourselves in some of them, but sure. I don't see no problem. Okay.
Well,
Well,
it's just
together.
since we're gonna review the video, it would be helpful to
Yeah, I'll send
have
this out. This is
the template.
basically all of your templates are in one sheet. So,
Can I ask one more question about the hypothesis? When you have the null, can you have new equals, standard, the sample, the X with the bar?
mhm.
And then the alternative would be mu doesn't equal the mean. You know
I
what
mean,
Is that,
that's never going to be an answer for your homeworks. That's more of a nomenclature for what you might use. X bar is representative of value. Whenever we're setting up an actual hypothesis test, we're going to know what that value is.
okay,
So that's X bar is representative of a single numeric value and not a sample. It's a numeric value. So for these, we're going to say, are they equal to or are they not equal to, knowing that there's a mean for a sample. Now we can say,
so what we would need
we can,
is
I mean, the
value.
proper nomenclature might be X of dollar general
Uh-huh.
is equal to X of Kmart. And X of dollar general is not equal to X sub Kmart.
Okay, so it wouldn't be mu.
No, mu is for a population.
Correct. So it
We're
would-
going to be dealing strictly in samples from here on out. Okay. So, when we're back on homework 3, conduct hypothesis test. We look at our p-value. P-value is 0.013. That's going to be less than our alpha. So for our hypothesis test, our conclusion would be that we would reject the null, that these two sample means are equal to each other.
Can you put the formula for your p-value?
It's right here. Click on it. It's just your
It's not your p-value, I meant the z. Wait, yeah.
p-value.
Why is mine different?
So you said reject the null hypothesis, what was that, when the numbers?
So our p-value is less than our alpha value, so we reject the null.
So when the P
Oh,
is
okay.
low, HO must go.
And why is it times
I
2?
love it. Your p-value.
Because remember when we did that thing with it, it's always going to be a two-tailed test. So we did that, we had that question about a two-tailed test is more stringent than a one-tailed test. So we look at the lowest one-tailed test. Our two-tailed test is always going to be double that p-value for a two-tailed test. It's a more stringent test. If we want our p-value to be low, we're doubling our p-value. So our p-value for a one-tailed test must be a lot lower, if that makes sense.
Yes. Yes,
What is
reject the null when our p-value is lower than the alpha. For number,
I don't have it either. Yeah, the template didn't have that times 2.
I know he's talked about that.
which one, I'm sorry?
The p-value.
When I plugged it into the template, I got 0.0069.
0.0069.
Mhm.
That's what I thought too. That is the lower limit. Difference between. So, Matt, are we still on tab A?
Yes.
There's no similarities between the satisfaction.
Yeah.
Okay.
Yeah. So what's our conclusion?
So there's no similarities in their level of satisfaction. So
So
we
rejecting
rejected
them all.
all, the alternative is accurate, and the alternative is that they're not similar. Did I confuse you more?
Mhm.
Maybe times 2 in the chi-square test or something. That's a different time.
So you have to have that, your template that you've got, that you were given is incorrect. And my template is correct. Because your template is only doing a single tailed test. And so if we were to say for your template, switch this up. So your template came like this, 77 and 72. And it makes sense. But if we were going to test the difference between these two, we just switched them up. We made this one 72 and this one 77. And this one 30. And this one 25. Then the p-value is going to be all crazy. 25? So a p-value of 25. A p-value is going to be crazy. So we're looking at a one-tailed test. The way your template is written, and you need to multiply it by 2 to make it a two-tailed test. I'm not sure.
Did you get a number? Yeah, did you get a number? That's what I was just saying. Maybe I did before.
That changes like everything.
So I would roll with, I'll send out my template, and I'd roll with my template over your template.
Thank you, Matt.
Okay, so what is the p-value? P-value for this one is 0.013. What is the lower limit of the confidence interval? Lower limit is going to be 1.63. And the upper limit is 14.37. So what that means is we know the difference between the two population score, the difference between two scores for the populations, we think is between 1.63 and 14.37 with a 95% confidence.
Could you repeat that? The equation that we have, look at the parentheses of this. If you, we got negative numbers for our p-values,
Yeah, I got a negative.
and it's in the way the parentheses are done.
So
You got the 1 minus.
Yeah,
No, you keep the 1 minus, but you just put it.
so you have to go
How am I
equals
gonna know that?
parentheses.
Because you're going to,
No, the way
uh,
math works.
hold on, I see that.
No. Two tail?
You have to have,
No, not the two. The format in Excel set. It's a negative number.
this is,
So
yeah,
once I
this
put
is
the parentheses different, then I didn't think negative number anymore.
Put the parentheses.
How to put it in
Oh,
front.
before that.
stop reading on
We're still rejecting it.
Oh, okay.
Right?
Okay, so the p-value is
Yes.
0.014. And the
Yeah, the
alpha is
answer is that the
0.05.
customers do not have similar satisfaction level of these two stores.
I shouldn't have those going to change because we times it by 2.
Let's just do this.
2-1 now. What was our- I have no idea. I know it's getting strange. Don't make a difference.
I honestly do, I'm like, this is better.
My child is going to go to bed.
I could do that, I could do that. I could do that. So just let this come down. Mhm. And so the way that my daughter's coming for questions come around, and then she's all set on it. I can't help her.
Well, yeah, we're into it.
Wanna leave it?
Mm-mm.
He would be really good.
That's what I do. My daughter doesn't know how to do this. Like, we did it with 18 times 6. Okay. She didn't know to stack it like that. They make them break it down 18 6 times. Okay, and then they pair it together and then they do 10 here and then 8 plus 6 is 16 or something. It's so crazy.
I didn't know.
What is that?
What grade shit?
Fourth, they basically took the multiplication out of it and turned it into addition.
Yeah.
I'm like, just stack it. What's 8 times 6? And then she broke down 8 times 6, like all broken down into addition. So they keep changing it into addition. I'm like, memory's for you. Second thing, how are you supposed to do that? I know. And she literally sits with this huge whiteboard at my desk when she does her homework to break it out.
And we're just in mistakes.
Because you met, I mean, yeah, because there's just so many steps now. Except she just knows it though, like she just can't lift it off. But she's in common course and she just learn.
Sounds like fun.
Okay, so,
How to break it out.
I'm gonna say multiply it by 2. But that's just because usually when we're finding the p-value using a normal distribution, we always multiply by 2 since it's a two-tailed test. I don't know why my template and your template is different, but I'm gonna say if this template that I sent out to people for the final exam has multiplied by 2 in it, there's probably a very specific reason to get that. So just change your templates on that one. If you don't change your templates, then either way, we're in the same conclusion. We're supposed to be multiplying this by 2 though, because if we do not multiply it by 2, then we're not taking the proper two-tailed p-value. So
So we multiply the whole thing from the 1 minus norm dot s distribution.
the
Mhm.
whole output there, that by 2.
output.
So put the whole thing in parentheses by 2. So other questions on A?
Where's the concept of the point estimate of difference falling between the lower and upper limit come in?
Okay, that's good. That's a good question. So our point estimate was the difference between our two sample means.
Which was 8.
So we have 8.
Mhm.
So then what we're able to do is given we can make what we call a confidence interval. So confidence interval is we're confident at 95% that we're going to fall between the true point estimate falls between these two values. So it shows that we have a pretty big range here with the two values, but what's not included in the range is 0. So our lower limit's greater than 0, upper limit's greater than 0. So if both our lower limit and our upper limit are greater than 0, then we know that with 95% confidence that the difference between the two is greater than 0. If we know the difference between the two is greater than 0 with 95% confidence, then we know they're not equal with 95% confidence. That's pretty much the big concept there. Is we can not only get a pinpoint estimate, but we can kind of these upper and lower tails of a confidence interval give us a better idea of what we're actually looking at. And the best way I kind of explain that is if we look at like political polling, and so say in political polling, one candidate has a 2% or a 4%, say a candidate has a 4% lead in the polls, then there's a 5% margin, there's a plus or minus 5% margin of error. That means that their true lead is actually somewhere between losing by 1% to winning by 9%. So the confidence interval gives us more information. So even though we see that they have a 4% lead in the polls, we know that the true lead is highly questionable. It could be within the realm of realistic possibilities that we lose it.
So in that case, since 0 is in between the upper and low
Upper
limit,
and lower bounds.
we failed to reject. Got it. In other words, they're statistically similar.
Yeah, they're really simple. So
Got it.
we have the gist that one person has a lead in the election, but like really we don't know the true outcome because we're basing this all off of samples.
Got it.
Other questions in this one?
So just to clarify, the answer would be that the customers are not equally satisfied for these two stores.
Yeah, so when they ask us like this question here, what is the conclusion? The conclusion would be that the customer, we would reject the null, and our conclusion would be that Dollar General and Kmart customer scores are not equal to each other.
And the p-value actually supports this.
Yep, the p-value
Right.
is yeah.
Because of it's 0.013.
And so we could say though, also, since we see that, since we know that Kmart has a higher mean score than Dollar General does, and we know that statistically those two scores are different, are not equal to each other, we know by logic that Kmart has a higher score than Dollar General. Okay, B. What's the point estimate difference? Okay, well, college data reports annual cost of living. So, what is the mean for a private college? We can just do this as average private. And so what's the standard deviation in sample costs for public colleges? We can just go standard deviation of a sample. And so is the point estimate difference between the sample means significant? That's a weird way of putting that. Is the point estimate difference between, let's just assume that the point estimate difference is 0, because it doesn't give us one off the board. So what we're going to do is we're going to go to data. What are we looking at? So data, we're looking at 2 sample tests. So these last 4 are the ones we're going to be talking about. So are we going to use a z-test or a t-test? T. And why are we using a t-test?
We don't know the standard deviation.
Because we do not know the population standard deviation. So since we do not know the population standard deviations, we're going to use our t-test. So we're going to do a t-test for 2 sample means. And we're going to assume, since we're always going to assume unequal variances, unless it specifies otherwise, it doesn't specify here that they're equal, so we're going to assume unequal variances. And then we'll get to paired tests later on. Paired tests where we have one person or animal or thing outputting 2 paired points. This one, they're clearly not, they're not even matched up and equal, so they're not paired. We're going to assume unequal variances.
Matt, I know that you said that we assume because we don't have that, but we could also assume that they're equal. Like, can you give us a little bit
No,
more?
we're going to assume that they're not equal, because that's a very strong assumption to make that they're equal. So there's 2 assumptions to make. We can assume that they're unequal, or we can assume that they're equal. And assuming that they have the same variances over different samples is not a very good assumption.
Okay, gotcha. Okay, I didn't know you. Okay. Thank you.
So for this class, always basically we're going to be using the unequal variances.
Okay.
So range 1, we're going to paint up private schools. Range 2, public schools. we included the labels, and we're just gonna output it somewhere on the sheet. Our alpha value here, we're able to change this alpha value whenever we want it. If we're given a hypothesized mean difference, what?
I guess this is what I was talking about.
So if we're given a hypothesized mean difference, we can enter that there. So if it said, are private schools $10,000 more expensive a year on average than public schools, then we could put 10 right here.
Oh.
This one doesn't specify a mean difference, so we're going to put 0 for this one, but it can specify, and we can put a value there. So 0 is going to output this here. So here we have the means and our variances. And remember, we said our sample standard deviation for public colleges is that. So our sample standard deviations would always be the square root of our variance. And we do a sandy check here, and we see that that is true. These two are equal to each other. So that's good. Do that properly. So if our point is, so are we saying, are these two, our public and private schools, are the mean values different? We look here, we can look at the two different means. We know just from spot checking that looks like a pretty big difference. Variance, we can see the public schools have less variance, so we probably know that we probably can just feel by eyeballing it, feel more confident that this difference is going to be statistically significant. Then we're doing a two-tail test. We go all the way down to a p-value for a two-tail, and it says something weird in scientific notation. That's okay, we can just format that differently. So our p-value is essentially 0. So, is there a difference between the prices of a private school and a public school in this question? Two-tail test, equal to, not equal to. We're going to reject the null of them being equal. So there is a difference in the price between a private school and a public school.
I'm sorry, how did you change the format? I keep adding zeros and then I can get rid of E.
So go click on it.
Uh-huh.
This one right here is the same thing. Click on it, go up to number, and then just click that comma.
Thank you.
So if we use a template for interval estimate of difference in population means on an unknown case, like you had up there earlier, it gave all the same information.
Yep. What?
It gave all the same information.
It does, yeah.
Okay, so either one's right.
Yep. But if we're given data, it's easier for us to do this one because it was just one click and populated it for us. But if we could have a question where instead of giving us data, they give us the mean. They give us the mean and the standard deviation, sample standard deviation. Then we can use the template and plug in the values into the template. So we kind of have both tools. If we're given the data, the best way to do it is this way. If we're not given the data, the only way to do it is through the template.
So you're saying that when the sample means significant with the alpha, we're saying yes, it's significant? Or no?
Yeah, the way this is worded is bad. So it's the point estimate difference between the sample mean significant with the alpha. They did not give us a point estimated difference. So we're assuming the point estimate difference is 0. So we're saying if the point estimated difference is 0, we're saying are these two means not equal?
Mm-hmm.
And if that's what we're saying, yes, it's significant. The point estimate difference is significant. I would just write out there, the point estimated difference of 0 is significant. These two means are not equal to each other. And then what is the p-value? The p-value is given to us here. It's a two-tailed test.
You said the point estimate is statistically significant, and what else, Matt?
The two means.
The two means are not equal to each other.
Two means, thank you.
So tab C says, consider the results for math and writing scores for a sample of 12 students below. Are there differences between math and writing scores for samples significant at, where does it say this? Okay.
This would be the paired one, yeah?
Yep. So We're assuming here our null hypothesis is that writing scores and math scores are equal. Our alternative hypothesis is that writing scores and math scores are not equal. So each student took both tests. So each student gives a data point. So we're right, that is a paired test. So we can go to t-test sampling, t-test paired 2 samples for means. So range 1 is math. Range 2 is writing. Labels, our hypothesized mean difference is 0. We're going to put output, we'll populate it right here. Does that?
Yeah.
Ooh. So, standardize all this into counting. So, given an alpha of 0.05, are we able to say whether or not these two means are statistically different? That's a two-tailed test. If we go down to our two-tailed p-value, two-tailed p-value is 0.039. That's going to be less than 0.05. So, are there differences between math and writing scores? Yes. There is differences. We reject the null of them being equal. So that means that there is differences between our math and our writing scores. So what is the value of our test statistic? We'll give our t statistic right here. Our value of t statistic is the 2.337. Our p-value is what we just discussed. And our degrees of freedom is calculated here is 11. What is the point estimate of the difference between the mean scores for the two tests? Our point estimate is just going to be the difference between our two means. So our point estimate is going to be our 514 minus our 489. Our point estimate is going to be 25-point point estimate.
Where is this 35 that you said?
35, 25.
25.
Oh, for the difference.
Yeah,
Oh, no,
that's
okay.
a point estimate. Point estimate is the difference between two means. Yeah.
Now, so did we do the t-test because the population is unknown?
Yeah, the population standard deviation is unknown. Yep.
Okay.
And then we did paired. We did a paired t-test because
Compare the-
one student took each test. So all of our two samples are paired together because they come from the same population of students, and each student produced two values.
So now, the two critical,
Mhm.
why didn't we use that here, and why did we use it in the last one?
Did we use it in the last one?
We used- Not the last one, we used T critical one for one of them.
We use 2 sample assuming an equal variances. Is that the one you're talking
No, I'm
about?
talking about when we used the T critical, I think.
Oh, so T critical, we could use it here too.
Oh, can we?
We could compare a T critical to our T stat. So our T stat is greater than our T critical, and thus we reject the null.
Oh, okay,
But I just use the p-value test as easier test than
Right,
the
that's right.
T test.
okay, I remember.
So tab D, 4 different paints are advertised as having the same drying time. Plain, 5 samples taken. Which paint has the fastest drying time? In order to do that, we just take the averages of all 5 of these. But that'll do that when we do our ANOVA test. So we're gonna go here, we're gonna go to ANOVA single factor. This is our input. Our inputs are divided by columns, and we have our labels in the first row. Our output range, we put it right here. So, which paint has the fastest drying time? The fastest average drying time is paint 1.
We could have done that just by doing the averages,
Yep.
correct?
We could, but when we do, we're going to need to use this later on for the other questions. So it's just easier to kind of do it.
Wait, how do
So go,
we know paint one?
What?
It is the lowest
Table one
average.
is the lowest average.
Right, what we're looking for is the average.
The average,
but
I'm looking at the variance, because I thought everything with A number was about variance.
No, it just asks us what's the fastest drying time, and so just, which one is the lowest speed. So the second one says, are the differences in drying times statistically significant? So, we look at our F-stat, and we look at our F critical value, or we can look at our p-value. At an alpha of 0.5, our p-value is 0.09. So, in this null hypothesis is this. We can have our null being that mean 1 is equal to mean 2 is equal to mean 3 is equal to mean 4. And our alternative is that H null does not hold. So, question says, are the differences in drying time statistically significant? And so, in order for that to be a yes, we need to reject the null hypothesis. But our p-value is 0.09, our alpha value is 0.05. We're going to fail to reject the null hypothesis. So thus, the drying times in paint are not statistically significant.
Since the p-value is.
Yep. So assume that the sum of squares within each group remains the same. What is the minimum sum of squares between groups where the analysis will result in a significant drying time? Okay, that's one thing we don't like this question. Variances. What chapter is this from? See what chapter that covers this. There's in the book somewhere you're gonna have this ANOVA table as a formula. Where is this grocery store? $593 looks like. No, that's not it. What is this page? You guys know what page your ANOVA table is in your book?
Oh,
Okay.
it's not 592? No?
No, that's the wrong one. It should be more in chapter 10, I believe.
Yes.
You said it wasn't.
You said it wasn't. 592, that's what I thought it was.
592 to 593.
It was a multi.
No, let's go 577. Okay, so question.
Oh, yeah.
Assume that the sum of squares within groups remains the same. What is the minimum sum of squares between groups that will result in the analysis being significant? So, our sum of squares between groups our MS, or mean of squares between groups, is going to be equal to our sum of squares between groups divided by degrees of freedom, which for this will always be 3. And what we need our F to be equal to we need our F to be greater than this critical value, so we need our F to be over 3.24. So we have to increase this number. I don't want to do this out. Okay, so
Can you tell us what we're looking for first, than anything before we start with the formulas? Because that kind of like helps
So-
understand what we're doing with the formulas.
So for this, if we look at our ANOVA table, the sum of squares between groups, which is going to be a sum of square treatments, all of these kind of flow together with creating this table. So the question he asked you was, say that your sum of squares within groups remains the same. What value of your sum of squares between groups would you need in order for this test to reject the null hypothesis? So what value here would make our F value greater than our F critical value? So if our F value is equal to our mean square between groups divided by our mean square within groups. So if we're keeping our sum of squares within groups the same, our mean square within groups is going to be given to us. So our F value is always going to be our mean square between groups divided by 43.25. And we need this to be greater than 3.24. So we can solve for that by multiplying this whole thing by 43.25. So our mean square between groups must be equal to 43.25 times our critical value, 140.08. So this is what we need our mean square between groups to be equal to, 140.08. So now we know that from looking at our table, our mean square between groups is equal to our sum of squares between groups divided by our degrees of freedom. And we know our degrees of freedom is going to remain the same at 3. So our sum of squares between groups divided by 3 is going to be equal to 140.08. To solve for this, we multiply the whole equation by 3, and our sum of squares between groups would have to be equal to 420.08. 0.24. I don't know really how to explain that to you other than this is this is just algebra given,
Yeah.
because it doesn't really make sense to explain to you how we could end up in a spot where our mean square between groups did not change, but our sum of squares within groups, and within groups didn't change, but our sum of squares between groups did change. It's kind of a funky, wonky idea. But the idea is that this sum of square variance between groups, if the variance between groups increases, then we're more likely to prove that the means are different between groups. And if it doesn't, and if our variance within groups is just a relative measure, but what happens is the way we can prove that groups have different means is if the variance between those groups is different. I know this is all kind of algebra. He might ask you questions like this in the midterm, and we'll go over the algebra a little bit more. But it's just a plug and chug algebra of these numbers are fixed, these numbers are not fixed. Solve these numbers if these numbers are fixed. And I think in your midterm review, I'll send you a full layout of these are the formulas within Excel if we were to lay out this table in Excel, but it's just all algebra, more or less.
Can I ask if you will be so kind as, I need to know what all this stands for, the sources of variation. So SS would be sum of squares, DF is degrees of freedom, MS?
It's mean squares. So we have sum of squares and we have mean squares. Sum of squares, mean squares is sum of squares divided by degrees of freedom. For both of these, our F value is our between groups mean squares divided by our within group mean squares.
And the F?
That's it. It's this number divided by that number.
Okay.
It's the F value. Our F critical value is calculated based on an alpha that we already give it, and our p-value is F distribution of this.
Okay, but what the F stands for, besides the formula?
That's your F test statistic.
Oh, okay.
He's gonna give us a table that we're gonna have.
Okay. And then the F critical is the value, or how did we get there? Because there's another exercise later on when he gives us a few numbers and then we need to
Cross
the
them over.
formulas. Yeah.
F critical is given to you by your alpha value and your F dot distribution. So our alpha value here,
Alpha value and what again? I'm sorry.
your alpha value
Uh,
here, that's specified in the question,
Oh, okay.
that's your alpha value. So F dot distribution
Mhm.
or it's F dot inverse right tail of 0.05. Our first degrees of freedom, our second degrees of freedom. Is going to get our F critical value. For our F value, for our P value, is going to be equal to F dot distribution, right tail, of this, our F value, our first degrees of freedom, our second degrees of freedom. Will give us our P value. So this one here, we just look at our formulas in our book. We know that our error term must be the difference between our total and our degrees of freedom. I mean, our total and our sum. So it says here the shows test with 5 factors, given 7 observations within each factor. We look at our table. Our treatments are 5, so 5 minus 1 is going to be our treatment degrees of freedom. And then our error degrees of freedom is going to be the total number of observations. We have 5 different effects or 5 different things that are changing. We have 7 observations within each of those. So our total N is 35, and then we subtract out our K, which is this number above it. We have the 35, so our total degrees of freedom will be 35.
Oh, I thought K was 5.
Can you show the formula again, please? So you
Yeah,
take
K is 5,
35
my bad.
minus 4.
It's 5.
Okay.
Which formula?
No, never mind, because I have it like 30, I don't have it 31, so that's why I was kind of curious. Thank you.
So the mean square is going to be just our sum squared divided by our degrees of freedom for both of them. So we just copy that down. Our F value is going to be our treatment mean square divided by our air mean square. And then our p-value is going to be F dot distribution. We're doing a right tail test here. Our F value, our first degrees of freedom, our second degrees of freedom. And that should be our p-value.
We know it's right tail because it's not negative, right? Or,
No, for a NAMA test, we're always going to do right tails. So there's always remember the right tail for that. Question?
So that would be upper, right, when we said right?
Yep, upper tail, yep.
Thank you.
Okay. Do p-value tests. I'm going to send out this review in a write-up on chi-squared in case you guys aren't here tomorrow, because I have to go. It's been a while. But,
No particular reason.
some reason. But, so I'll send out that write-up on F through I. How many more are going to be here tomorrow that are here today? So if you aren't going to be here tomorrow, shoot me an email and I'll send you a write-up on tabs F through I. But they're pretty easy. Chi-squared is a little bit confusing, so when is this homework due?
Tomorrow night.
Tomorrow.
Midnight.
Tomorrow night or tonight?
Tomorrow night.
Tomorrow night, yeah. So I'll send you that email tomorrow during the day. If you have any questions or need to call me, let me know. I can send you a number. Chi-squared is a little bit different and a little bit more difficult, so you might need some help walking through that. But we'll go over these other four tomorrow.
Are all four of these the time?
No, these ones are proportional tests. So these ones we're going to use these population proportion templates. That's tab E, tab F. Tab G is proportion as well. H is going to be a chi-squared, and so is I. H and I are both going to be chi-squared.
so F and G are population proportion.
Yep. Let's go here.
So you'll send them tomorrow by noon? You said.
Are you going to be here tomorrow? Because we'll cover them tomorrow. So I'll just cover them tomorrow. Everyone who's not going to be here tomorrow, send me an email and I'll send you out. I'll send you out.
Okay. Do you want me to send you the email tomorrow?
You can send it right now. Let's see here. Finds it all. So. Okay, let me know you guys get that. Oh, what the doctors?
There, 1, 3. 9, 3.
What are you calling this? That you're emailing us?
It should say final review, final exam review guide. And I just put templates as the word in the. I send it to all these people. I don't know why I show it. Why some people's emails have names attached. It's
Oh, there's still some, oh, let's see, Mike is still in there. No.
Hopefully no one's like not in the class anymore.
Is that Michael?
No, if you're following the one that I sent you, Matt,
It should be-
then it should be just as the 21.
Did you guys get that email?
I got it.
Okay, good.
Thank you. It really helps. That's why I need to review the video later.
Thanks, Matt.
-1 was sport park. Then I kind of find out that that's not.
Thank
even
you,
right.
Matt. I really appreciate it.
Something about what
Something
About
that, you know,
It helps a lot.
as in coaches and community, I don't even. I was in school before you.
We're like,